On today's show, we're diving back into Cura 3.4.1 and taking a look at what we can improve on our prints. Hey, welcome to The First Layer. My name's Richard Cleveland. I'm your host here 3 times a week. I'm so glad you're with me today. If you watched Friday's show, you know that we dived into Cura 3.4.1. We set up the Ender 3 on Cura 3.4.1, the latest edition, and then we went ahead and sliced up and printed the model that you see in my hand today. This is the vintage Spider-Man bust from 3DNG. You can find this on Thingiverse. We'll put a link down below in the comments or in the description, pardon me. If you printed this one over the weekend, please put your photos of the print up on our Facebook page or include them down below. Now, I want to talk a little bit about this. We're going to go over to this shot here. And what I want to talk about is this is not a perfect print by any stretch of the imagination. There are some good things about it, but one of the most noticeable things, and I saw this on a couple of prints over the weekend, is that the layers seem to be just slightly shifting or over extruding on the outer perimeter of the layer. Now on the back it's fine, on the top here it's fine, but you can see that there are some lines on the back of the head and across the chest and across the spider. Now, I haven't fully cleaned this yet, but is this an acceptable print? Yes, it is actually. I would use this print. I would go through and sand down things like I normally do. XTC might take care of some of this, but I would definitely go ahead and sand that down, and then I'd get it ready for primer and paint. However, we can improve upon this, and today I'm going to show you how. What we're going to do is we are going to head over to the computer. We're going to dive right back into Cura 3.4.1. We are going to use some settings from a YouTuber by the name of SandTube. I discovered his profile on Thingiverse on YouTube over the weekend, and I thought, well, you know what? Let's try and refine it, and we'll give it a try. So let's head over to the computer, and we'll get started. All right. So we are now in Cura. We're over here at the computer, and we're going to start with our settings. So we set up initially onto Cura 3.4.1 on Friday. So let's go in and let's just start looking at our settings. Now, you guys will remember that when I said that you should be at 0.2 for your draft quality, I wasn't lying to you, but initial layer height, according to SandTube, should be 0.26. Now, I always round up by 1. I always think that gives me a better layer for my initial first layer. But in this case, we're going to go up just a little bit. So it's going to be 0.26 in this case. We are going to go down to our line width, which is going to be 0.4, and we know that that's 0.4 because of our nozzle size, and we know that our nozzle size is 0.4. Now I'm going to leave my initial layer width at 105, although he suggests that you put it down to 100. I like to have that little bit of extra material to get me the best adhesion to the bed. So now we're going to move on to the shell, and that'll be the second one down. So moving on to the shell, I changed a few things. I typically will make my walls 3 layers. Now you don't have to do that. You can actually just leave them at 2 if you only want, a 0.8 millimeter wall. But if you want to change that, you can also do it up in the layer thickness by adding 0.4 to 0.8. And that will give us, if we do our math right, 1.2. Now that will automatically do our line count at 3. Now I like that little bit of extra thickness on the shell of my prints, because if I'm going to be sanding, I want to be able to have enough material there that I can sand a little bit of it away and not lose any detail. So I'm going to leave that at 1.2. Now our wall count, we just talked about those. Let's go to outer wall wipe distance. Now this is something we didn't talk about. And what the outer wall wipe distance does is it's the distance of a travel move inserted after the outer wall to hide the Z-seam better. And that Z-seam is that which goes all the way down your model. So we're going to leave that at 0.2. We're going to move down to top and bottom thickness. In this case, we're going to go 0.6, which is a multiple of 3 of our height. That's our top and bottom thickness. So we're going to have 6 top layers. We're going to have 6 bottom layers. In this case, we're going to have a zigzag top and bottom pattern. We are going to optimize our wall printing order. So we're going to make sure that that is checked off. We're going to compensate for wall overlaps, so we're going to have that checked off, compensate for outer wall overlaps, and compensate for inner wall overlaps. We're going to fill gaps between the walls everywhere. We are also going to filter out tiny gaps, so you're going to have that one checked off as well. Now, when it comes to the Z-seam alignment, we are going to make sure that this is the sharpest corner, and we are going to hide the seam. Ignore all Z gaps, so it's checked off. We're also going to enable ironing, and what ironing is when it does an extra sort of smoothing of that top layer by applying heat to it, the heat of the nozzle. So it's just going to go over after it's laid down. It's going to kind of iron it out, give you a nicer finish. Our ironing line spacing is going to be 0.1. We're going to leave all of this just as it is. Our ironing acceleration is 450, and our ironing jerk is set to 10. So we're going to close this one up, and we'll move on to the next one, which is infill. Now, our infill density is going to be 15, and our infill distance is going to be 8.0 millimeters. So 15% is all we want for our infill density. We can lower that or we can make it higher depending on the material that we're using. We're going to use the triangles pattern again. We are just going to quickly run through some of these. Infill overlap percentage is going to be about 10%. Our infill overlap is 0.04 millimeters. Our skin overlap percentage is 5. And then our skin overlap is 0.02. Now, infill wipe distance is going to be 0.2 millimeters, and our infill layer thickness is 0.2 as well. Now, our skin removal width is 1.2 millimeters. We're going to leave all of this just the way that it is. We're not going to touch any of that. Now, let's go on to the material, because there's a couple of things we want to do here. We are going to make sure that if we're printing with PLA, that we are printing at 200%, or 200 Celsius, pardon me, 200 degrees Celsius. We are going to default our bed to 60, that's just fine. We are going to have our flow set to 100% and our initial flow at 100%. We want to make sure that we've enabled retraction as well. And now we're going to set our retraction speeds and our retraction distance. So our retraction distance is going to be 7 millimeters and our retraction speed is going to be 60. Now your extra prime amount is going to be 0.05. This is important. And your retraction minimum travel is going to be 0.7 millimeters, okay? So if we set those like that, we should have a much better print. We're going to do a print, and we are going to check it out on Wednesday, because it does take a little bit longer to print. So we are done with that. Now let's move on to speed. And we are going to, I know I'm probably going through this pretty fast, but you might remember on Friday I said our speed should be set to around 40 millimeters per second. Today we're going to up that speed a little bit. We're going to go to 55 millimeters per second, and our wall speed, our infill speed is going to be 55. Our wall speed is going to be 27.5. And I'll leave this up on the screen for a second so you guys can see this. Support speed 55, 55. Travel speed is 120, 27.5 for our initial layer speed. It's cutting that in half. As we discussed on Friday, we're going to enable acceleration control. If this is not checked off, please check it off. And equalize filament flow, we are going to leave that unchecked. Now our print acceleration, we had 500 on Friday. Today we're going to drop that down to 450. And our travel acceleration, we're going to bring up to 4,500 millimeters per second. And once you change those couple, you should be fine. We're going to enable the jerk settings on this one. If you didn't enable the jerk settings on Friday, let's enable them today, and we're going to set them to 10. Now, where it's important that we change one of these numbers is travel jerk. We're going to set that to 20. Now, I know I always say 5, but we're going to try some settings here. We're going to experiment. And this is all part of 3D printing. The experimentation to getting that best print, because every printer is different. Now, I kind of have my own universal ways of doing things, but I want to test out somebody else's settings and see how they work on the Ender 3. So we're pretty much done there now. You can pause this video at any time. So now we're going to go to travel, and we're going to start with combing mode, and we want combing mode all. What combing mode is combing keeps the nozzle within already printed areas when traveling. This results in a slightly longer travel move, but reduces the need for retraction. If combing is off, the material will retract and the nozzle moves in a straight line to the next point. It is also possible to avoid combing over the top and bottom skin areas by combing within the infill only. So there's something to keep in mind. And now our travel avoid distance is going to be 0.625. And we are also going to make sure that we've got Z-hop when retracted checked off, because we want to make sure that we are doing some Z-hop, and our Z-hop height is going to be 0.8 millimeters, okay? So now let us move on to cooling. Cooling's pretty simple. We want to make sure that our cooling is enabled and our fan speed is at 100%, and that our initial fan speed is set to 0. So we're not going to go too much into that. We're going to go into support next. And this is only if you need it. So on Spider-Man, we needed it. We want to generate support. We're going to put it everywhere. Our support overhang is going to be 50 degrees, and we're going to use zigzag as a pattern. And you can just kind of go through there. 15% is going to be our support density. Support line distance 2.6667. And then support Z distance is 0.1. Where things are going to change for you a little bit is right here where it says support XY distance. You want to make sure that that is 0.7. The rest of that is pretty much fine. You can just leave it the way that it is. You don't have to muck around in that. Let's go into build plate adhesion. Now in this case we are going to use a skirt. We're going to use a line count of 2, no more than 2. And then we are going to do a skirt distance of 5 millimeters away. So this is going to put our skirt, which is really good for priming, 5 millimeters away from our actual print. Now, when we go to mesh fixes here, we are going to make sure that some things are unchecked. Union overlapping volumes, you want to make sure that that is unchecked. You also want to make sure that remove all holes is unchecked. And then finally, remove mesh intersections is unchecked, okay? Then in our special modes, we want to make sure that we're printing all at once. That's pretty standard there. Now, in our experimental, there's a couple of things in here that we're going to talk about really quickly. And I'm just going to go down, and where it says tree support right at the top, you want to make sure that that is unchecked. You want to make sure that adaptive layers is unchecked, where it says here use adaptive, or pardon me, you want to make sure that this is checked. Use adaptive layers. Let's make sure that that's checked. And what adaptive layers does is it computes the layer heights depending on the shape of the model. Okay. Then we are going to make sure that our adaptive layers maximum variance is going to be 0.1, 0.01 for the adaptive layers variance step side. And then finally, we are going to leave our adaptive layer threshold at 200. So let's load in our model. Once again, we're going to go up here. We're going to load in a model. I'll load in Spidey one more time. Now, one of the things that I did not show you guys on Friday was how, let's zoom in a little bit, how to increase the size of Spidey. Now, we can do quite a few things here. We can go over to, first of all, you want to click on the model till it's outlined in blue and that you see these 3 arrows. These are our space X, Y, and Z in virtual space. Now, if you go over here to this side, you can see you've got a number of different things. Let's start at the top. We can move it to a specific location. We can scale it, which is what we're going to do. We can rotate it. We can mirror it. We can also do per model settings, so you can do different settings for different models, and then we can do a support blocker. In this case, we are going to scale it, and I know that on this machine, I can go to 150, I believe. If I do that, yes, and he still fits. Look at that. So I scaled him up to 150, and I'm going to keep scaling him, but now I'm going to scale him back here. 150. That's where we want it to be. We want it to be uniform scaling, and we are going to just close that out. Now, by using the right mouse, we can move around in virtual space here. And we can see when we zoom in, let me just move Spidey up here. You see that we've got this red line down here at the bottom. This is telling us that this is where it's going to put some support material. Anytime that we see a red piece, that's where our model is going to see support material. Now we can get rid of that a little bit. And how we do that is by, again, selecting the model, and now we're going to use the move. And we're going to move this on the Z in a minus increment. So we're going to go minus 0.1, and let's see where it goes. Minus, that's not quite far enough, so let's go minus 0.5. We almost get rid of that, so we are going to go minus 0.8. Let's try that. All right, so that pretty much puts us underneath, gives us a nice bottom. Shouldn't be any, well, actually there might be a little bit more. Let's go minus 1.0. See how that does. There we go. Now we have little to no red there. And we're not going to notice that 1 millimeter gone from the bottom. And we can have a look-see. We can get a nice close look. We can zoom out and see our Spidey model. And then we can move it around in 3-dimensional space. So there we go. So now what do we do? Well, let's make sure we are over in our layers view, and let's prepare the model by clicking the prepare button down in the bottom. It's just going to take a minute. So this tells me that it's going to take 21 hours and 57 minutes. We can see here where we've got our support material. That is all inclusive. We can see that we've got the bottom of our model here. And let's just see if we go down to the very first layer, did it actually took out that little bit of information that was on the bottom. So you can do that, you don't have to do that. I did it because I wanted a much flatter bottom. I noticed on the one that I did the other day, it didn't have quite as nice a flat bottom. So we are going to, let's go here and have a look at our infill. Our infill looks good. So now we are going to get this ready. We're going to save it to a removable drive, and we are going to head over to the printer. All right, so we've got our file ready. We've put it in the machine. We're just waiting for the machine to heat up now, and we are going to go ahead and start to print that. Now, that'll be finished in about 24, 25 hours, so by this time tomorrow it'll be done. What I would like you guys to do, though, is I'd like you to use those settings that you saw in today's video and try them out. Let's all kind of see what we can come up with. Now, the question of the day, what are your favorite settings for your Ender 3 or any printer that you use? With that being said, folks, I am going to jump out of here for today, and I want to thank a few people. First and foremost, my fantastic team, Brian Baker, Frank Awesome, and always the lovely Jess Corniching, who volunteered their time to come here and give me a hand to record these shows and do our live streams for you guys. I also want to thank my wonderful wife who works behind the scenes cleaning up all of these models that I do. She really enjoys cleaning them. I don't know why, but then she passes them off to me for paint. But she does a fantastic job cleaning them. I also want to thank my Patreons for all of their support. Thank you very much. It helps to keep this channel going, and it's always a great help. We've got a few more things we want to do in terms of bringing more equipment into the studio and getting things to the level that we want to get them to bring you guys a much better show. Now, if you want to become a Patreon, you can by going to patreon.com/thefirstlayer. There you can sign up for one of our different levels, and there goes the printer. Also, if you're not into a monthly commitment and you'd still like to show your support for the show, you can do so by going to Buy Me a Coffee at buymeacoffee.com/thefirstlayer. Every coffee helps, and we really enjoy drinking a cup or two around here once in a while. Now, with that said, I want to remind you guys to subscribe if you haven't subscribed. If this is your first time, go ahead, hit that subscribe button, hit that bell notification, and we'll let you know when we've got a brand new episode coming out, or when it gets uploaded, or we're doing a live stream. We also have a Facebook community that you can go and check out as well. If there's something you'd like to send into the show and have us review or have us take a look at, you can always send that to the address linked in the description down below. With that said, my friends, I want to thank Spool 3D. Last and but not least, Spool 3D provides this space for us. So Spool 3D, print it right, print it with spool3d.com or .ca, pardon me. They have everything that you need, from printers to filaments to parts, anything that you could possibly need. And their parts are expanding every day. Recently, they just brought in some Noctua fans for your 3D printers. So check them out today at spool3d.ca. Print it right, print it with Spool 3D. Now, with that said, my friends, I'll see you back here on Wednesday for our live stream at 1:30 in the afternoon. I hope you'll join us, and we will take a look at the side-by-side results, okay? So until then, remember that the first layer is always your foundation to a great print. Take care, my friends.